Hello students, welcome back to the sixth video of this playlist. So in this video we will be solving the sixth question from May 2023 Statistics 1 paper. So let's see what's the question number 6 from this paper is about. So basically the concepts behind this question, that is question number 6, it's from chapter number 4, that is probability, from your statistics 1 textbook. So to be specific, you have to deal with mutually exclusive data, even like mutually exclusive and independent data, independent events, and also you need to have idea about Venn diagrams. So let's get started with question number 6. Question number 6 from May 2023 Statistics 1 paper. So three events A, B and C are such that probability of A is 0.1, probability of B given A, this is 0.3, and probability of A union B, this is 0.25. At last, probability of C, this is 0.5. okay, so A, B, C are three events and their like some information about their probabilities are given. Okay, so in part A they said given that A and C are mutually exclusive, so we need to find out the probability of A union C. Fine. Okay, so this is very straightforward question, because since A and C are mutually exclusive, so for mutually exclusive events we know that A union C would be what? Probability of A plus probability of C. So probability of A is 0.1 and the probability of C is 0.5. okay, so that would add up to give you 0.6, and this is what the value for probability of A union C. Okay, next is part B. So in part B they are asking to show that probability of B equals 0.18. we need to show that probability of B is 0.18. okay, so they didn't mention anything about whether like B or A like are independent or mutually exclusive like as they did in part A. They didn't mention anything, just they gave some what probabilities. What probability of B given A is 0.3 and the probability of A union B, this is 0.25, right? So B given A, probability of B given A, what does it mean? So probability of B given A, it is basically equal to how much? If I show you using a diagram on the right hand side, if this is A and B given A, that means they should have it in the intersection, because if they don't have any intersection, then how could B, some part of B could be in part A, right? So there should be an intersection. So this is B intersection A, or A intersection B. This is A and this is B. Okay, so B given A is what? On A, how much part is B? Okay, this is what? B given A. So this is probability of A intersection B out of probability of A. Okay, so we know the value for probability of A, right? We know the value for A union B. We don't know the value for A intersection B, right? So what we can do is that they are asking the probability of B. Okay, so let's have a look. Probability of A union B is known to us, right? So A union B is what? Look, probability of A union B can be written as probability of A plus probability of B, okay, minus what probability of A intersection B, right? Do you know this formula? If you don't know, you don't need to memorize this formula. This is pretty straightforward. How? Probability of A union B, what does it mean? The whole of this circle plus the whole of this circle, right? So when you add, look, probability of A plus probability of B, so you can see that this intersection part is coming twice, once with the A and once the second time it comes with B. So to make it once, we subtract one of the intersection. Make sense? So this is how you can keep it memorized. Okay, you don't need to you can in this way you can keep it in your mind. You don't need to memorize. Okay, you don't need to memorize. Okay, so probability of A we know, probability of B we need to find out. So from here we can write, this is basically called the union rule for steps. So probability of B, it is equals to probability of A union B, okay, minus probability of A plus probability of A intersection B. Now figure out what are the things we don't know here. We need to find out, the question asks to find out the probability of B, right? So we know the value of A union B, it's given in the question. We know the value of probability of A. We don't know the value of A intersection B. So A intersection B can be written as what? Look at here. Probability of A intersection B, it is equals to what? It is equals to probability of A, which is 0.1 times the probability of B given A, which is 0.3. So if you multiply them, what you would get here, 0.1 times 0.3, that would give you 0.03. So we got the A value for probability, the value for the probability of A intersection B, right? So A union B, it's what? It's 0.25. So 0.25 minus 0.1 plus 0.3. So 0.3 plus 0.1, this is 0.4 minus 0.25 would give you 0.15. That means probability of B is 0.15, and that's what the question has asked for here. Okay, this is 15. Okay, this is what the question has asked for in part B of this question. Fine. Okay. Next is part C. Okay, before part C they said given also that B and C are what? Independent. Okay, so B and C are what? Independent. Independent means what? They will have an intersection. Okay, they will have an intersection. Okay, so the question asks in part C to draw a Venn diagram to represent the events A, B and C and the probabilities associated with each region. So we need to draw a Venn diagram. Okay, so definitely you have idea about Venn diagram. It's from chapter number 4, right? We have learned these like drawing Venn diagrams in chapter number 4 of statistics 1 book. So for part C they are asking for a Venn diagram. So we need a rectangle at first. We need a rectangle. It's a square basically, so I can extend it to make it rectangle. Okay, so we need to have 3 circles here, right, for A, B and C. Okay, so this has to be for A, B and C. So circles, 3 circles, A, one for A, one for B and one for what? C. Okay, we will rearrange them accordingly. Look, A, B and C. Now look, let's have a look. B and C are independent. That means B and C will have an intersection. Again, we have a probability for B given A. That means A and B will be also intersecting, but A and C are mutually exclusive, right? So that means B has part in A. So that means the middle, at the middle, B would be at the middle, and on its either side A and C would be. Okay, so that means if you consider this one, this is A, and this would be B, and this would be what? C. Fine. So we got this is A, B and C. So we need to mention the probabilities. This is the universal set, okay, and probability of A is 0.1. so probability of A is what? 0.1. okay, then probability of B is how much? Do we know the total? Yes, we know. This is 0.18. we know the probability of B, which is 0.18. okay, in this question I think I made a mistake in the previous question. Not a mistake, basically something I wrote in the calculation. 0.3 plus 0.25, this is 0.55. so 0.55 minus 0.1 would give you what? A union B is 0.25. okay, A union B is 0.25, and probability of A is 0.1. that's fine. And then A intersection B, it's basically 0.03, not 0.3. okay, that's what I made the mistake. 0.03. okay, so that would give you 0.18. okay, that's what the question has asked in part B. okay, so probability of B is 0.18. okay, so we got the probability of B. This is 0.18. okay, so we need to mark it here in the Venn diagram. This is 0.18. then what would be the probability of C? okay, probability of C would be B and C are independent. Since B and C are independent, do we know the intersection of probability of C is given 0.5. it's given as 0.5. okay, now since B and C are independent, that means the intersection will be what? The product of 0.5 times 0.18. so that would give you 0.09. so this is 0.09. 0.09. okay, and then the A intersection B, the probability of A intersection B is given. A union B is given, but we know the A intersection B, which is 0.03, right? We know this as 0.03. okay, so only A, it would be what? 0.1 minus 0.03, that is 0.1 minus 0.03 would give you 0. How much? 0.1 minus 0.03, this is basically 0.07. yeah, 0.07. so 0.18 minus 0.03 minus 0.09, so only B would be what? 0.12. so 0.18 minus 0.12, that is 0.06. 0.06. and only C would be 0.5 minus 0.09, that would give you 0.41. okay, so if you add them up, will you get 1? Let's check it out. 0.07 plus 0.03 plus, okay, 0.1 plus 0.5, since these two are mutually exclusive, so this is 0.6 plus 0.06, that gives 0.66. So nothing, none of ABC. This is basically 0.34. okay, and basically this is the what, Venn diagram. Okay, and for 5 marks you need to write all of these probabilities clearly on the Venn diagram. Okay, and that's all about part C. And just to notify you, like in part B, the previous part, in you have seen, like I wrote the value for probability of B wrong. There was 0.15. so keep an eye on it. Please make it correct by considering the value of A intersection B. I considered the value of probability of A intersection B incorrectly there as 0.3 earlier, so please correct it out. Okay, so that's that's all about question number 6 from May 2023 Statistics 1 paper.